In this video, I am going to solve the numerical problems for chapter 22, Reflection and Refraction of Light. First question. Microwave oven emit waves of about 2450 megahertz. What is the wavelength of this electromagnetic wave? The speed of the light in vacuum is given here, which takes the value 3 multiply 10 power 8 meter per second. So for finding the wavelength, we have to use the relation speed, which is equal to frequency multiplied by lambda. So here we are going to find the wavelength. So I have to rearrange this equation in terms of lambda. Therefore, lambda, which is equal to speed over frequency. So I'm going to take the speed of the light in vacuum. I'm going to substitute here. So by that, in the numerator, I have to multiply 3 multiply 10 power 8 over the frequency. Here they mentioned 2450 megahertz. That means in terms of 10 power 6. Clear? So mega stands for 10 power 6. Now I have to calculate this. 3 10 power 8 over 2450 10 power 6. The answer for the wavelength here is lambda equal to 0.1224 and the unit is meter. So this is the answer for the first question. Second question. A beam of light travels in diamond that has an index of refraction 2.45. What is the speed of the light in the diamond? So here generally the light initially travels from the air medium and it enters the diamond, right? Actually that air medium is not mentioned here, but generally how we are just going to pass the light in the diamond. So when you just triggering the light will be initially travel in the air and then it will be entered to the diamond, right? Second question. A beam of light travels in diamond that has then. Second question. A beam of light travels in diamond that has an index of refraction 2.45. What is the speed of the light in the diamond? So here the speed of the light in the vacuum here is given as 3 multiply 10 power 8 meter per second. As we know the formula for the refractive index. So what is the formula for the refractive index? The refractive index formula is given by the relation n, which is equal to the speed of the light in the vacuum over the speed of the light in the medium. So here better I can take the speed of the light in the vacuum. Here is v. So let's we take v1 as the speed of the light. Clear? So I can just change the number here. So this is v1. And what is v2? v2 is nothing but the speed of the light in the medium. So in this question, they ask you to find what is the speed of the light in medium. That means here we are going to find the value of V2. And what is given in the question? In the question, they gave the value of the refractive index of the diamond. So what is the refractive index of the diamond here? Which is 2.45. Right? So now I'm going to substitute these values in this equation, and for that first of all we have to rearrange this equation. So how we can rearrange? Because we are going to find the value of V2. So V2, which is equal to V1 over n. So here V1 is nothing but the speed of the light in the vacuum, and n here is nothing but the refractive index of the diamond material. So now I'm going to substitute the value here. V1 takes the value of 3 multiply 10 power 8 over, and the refractive index of the medium here is 2.45. If you divide 3 multiply 10 power 8 with the 2.45, we will get the answer for the speed of the light in the diamond medium. Clear? Okay. I'm going to divide 3 multiply 10 power 8 with 2.5. Let's see what's the answer. 3 multiply 10 power 8 over 2.45. I got the answer here as 1.224 multiplied with 10 power 8 meter per second. So this is the answer for the second question. Clear? Third question. An underwater scuba diver sees the sun at apparent angle of 45 degree from the vertical. The index of refraction of water is N2, which is equal to 1.333. What is the actual direction of the sun? Theta 1. The refractive index of the air here given as N1, which is equal to 1. And its related figure is given here. You have to see there the scuba diver who is inside the water. So he is the scuba diver, clear? And he is inside the water. He is seeing the sun at an angle of theta 2, which takes the value of 45 degree. And the refractive index of the water medium is 1.33, but the refractive index of the vacuum, that means the air medium, which is 1. So now we are going to find in which angle the sun ray will incident, which is theta 1. We don't know. We are going to find the answer for theta 1. So here theta 1 is nothing but the angle of incidence, and theta 2 is nothing but angle of refraction. So if you want to find the answer for theta 1, we have to use the Snell's law. What Snell's law exactly says? Snell's law says sine of I over sine of R, which is equal to N2 over N1. So here I stands for angle of incidence, R stands for the angle of refraction. Clear? And N2 refers the refractive index of the medium. Which medium? The water medium. Always the number 2 stands for the medium. And always N1, that means the number 1, indicates air medium. Clear? Okay, now we are going to use this rule for finding the answer. So let's we take here I is equal to theta 1 and R, which is equal to theta 2. Clear? Okay, I'm going to substitute this value in this rule. By that, this rule will become sine of theta 1 over sine of theta 2, which is equal to N2 over N1. So we are going to find what should be the value of theta 1. So what I'm going to do, I'm going to rearrange this equation. So I'm going to keep the sine theta 1 here. I'm going to move this sine theta 2 to the right hand side of the numerator. By that, this equation will become sine of theta 1, which is equal to sine of theta 2 multiply with N2 over N1. Clear? Now I'm going to substitute the value. So what's the value of this theta 2? The theta 2 here they mention as 45 degree. So sine of 45 degree multiply with N2. N2 stands for the refractive index of the water medium. What's the value? 1.333, right? Over, and N1 is the air medium, which takes the value of 1. So let's find what is the answer for this right hand side of the equation. So sine of 45 degree multiply with 1.333 over 1 gives the answer of 0.943. 0.943. So here we have sine theta 1, right? So now if you want to find the answer of this theta 1, so you have to move the sign to the right hand side. By that, this sign will take the inverse of sine, right? So therefore, theta 1, which is equal to sine inverse of 0.943. Clear? So inverse of sine multiply with 0.943 gives the answer of 70.56. What's the angle here? So theta 1 takes the angle of 70.56 degree. So this is the answer for the third question. Clear? Fourth question. A light ray of wavelength of 500 nanometer in air enters a glass plate of a refractive index 1.5. So if you read the first two lines, you will get the wavelength of the light in air medium. So what is the wavelength? Lambda 1. So here this 500 nanometer is nothing but the lambda 1 value, because they said this is the wavelength of the light in air medium. And here they mentioned the refractive index of the glass plate, which is nothing but N2. And they said air, so N1 is nothing but our refractive index of the air, which takes the value of 1. By using this, we have to find three answers. The first question, we are going to find what is the speed of the light in glass. And the second question, we are going to find what is the wavelength of the light in glass. And the third question, we are going to find what is the frequency of the light in glass. And here, the speed of the light in the air medium is given as 3 multiply 10 power 8 meter per second. So if you want to answer this question, first of all, we have to know the Snell's law. What Snell's law says, sine of theta 1 over sine of theta 2, which is equal to n2 over n1, which is equal to v1 over v2, which is equal to lambda 1 over lambda 2, right? So what is theta 1 and theta 2? Theta 1 is nothing but the angle of incidence, and theta 2 is nothing but angle of refraction. And here n2 is nothing but the medium. Which medium we are going to use in this question? In this question, we are going to use the medium as the glass plate, right? The material. We have two mediums. One is air medium. Second one is the material medium, right? So here the material we are going to use is the glass plate. And this V1 stands for the speed of the light in vacuum. Generally, the speed of the light in vacuum we consider as 3 multiplied by 10 power 8. So this value is approximately closer to the speed of the light in air. So we will consider this V1 is nothing but the speed of the light in air, which takes the value of 3 multiplied by 10 power 8 meter per second. So I am going to take, this is V1, right? And V2 is nothing but what is the speed of the light in the medium. What medium we are going to use in this question? We are going to use the medium here is a glass plate. That is V2, which is equal to the wavelength of the light in the air medium over the wavelength of the light in the given medium, which is glass plate. Clear? So that means here 1 stands for air medium and 2 stands for the material medium. Clear? Okay. Now, if you know this relation, we can solve many questions. So if you read the question, first of all, you have to identify what are the informations given here. In this question, they give the lambda 1 value, they give the value of the n2, so and also they give the word air, right? That means air is nothing but n1. That is refractive index of the air is always, which is equal to 1, and also the speed of the light in air, which is equal to 3 multiplied by 10 power 8. If you know the relation, we can easily find what is the answer for the first question. So in the first question, they ask you to find what is the speed of the light in gas. That means we are going to find the value of V2. So for that, we no need the information for this theta 1 and theta 2. We no need the information for theta lambda 1 and lambda 2. Clear? So the only important thing, this part. So I'm going to use this part for finding the answer. So let's we take this bracket, which is n2 over n1, which is equal to v1 over v2. So for answering the first part, so what I'm going to do, I'm going to take n2 over n1, which is equal to v1 over v2. And in this question, we are going to find the value of v2. Therefore, v2, which is equal to n1 over n2 multiplied by v1. I simply rearrange this relation. So now I am going to substitute the value. What is the value of n1? The value of the n1 is nothing but the refractive index of the medium, which takes the value of 1 over the refractive index of the glass medium n2, which is 1.5 multiplied with the speed of the light in air, which is 3 multiplied 10 power 8, right? So if you work out, you will get the answer for what is the speed of the light in the medium. So let's wait for getting the answer for the first question. So 3 multiplied 10 power 8 over 1.5. I got the answer as 2 multiplied with 10 power 8 meter per second. So this is the answer for the first question. Clear? Okay, now we have to come for the second question. What is in the second question? We have to find what should be the wavelength of light in the glass. So what I'm going to do for taking this answer, I'm going to use either I can use n2 over n1, which is equal to lambda 1 over lambda 2, or if you want, you can use v1 over v2, which is equal to lambda 1 over lambda 2. In both ways, you will get the same answer. So for getting the answer for the B, what I'm going to do, let's take these two, because v1 is given in the question, but v2 just before we found. Am I right? So let's take these two parts. So what is the two parts? v1 over v2, which is equal to lambda 1 over lambda 2. So in the question, they already gave the value of the lambda 1, which is 500 nanometer. And V1 is the speed of the light in the air medium, which is 3 multiplied by 10 power 8. And V2, just before we found the answer in the first part. So I'm going to take the answer from the first part. And now I'm going to substitute the value in this equation. Before substituting the value, I have to rearrange this equation in terms of lambda 2, because we are going to find the value of lambda 2 in the second part, right? So therefore, lambda 2, which is equal to V2 over V1 multiplied with lambda 1, right? So I'm going to substitute the value. What is the value of V2? I'm going to take the answer of the first part, which is 2 multiply 10 power 8 over the speed of the light in air, which is 3 multiplied by 10 power 8 multiplied with lambda 1. What is the value of the lambda 1? Here the lambda 1 is 500 nanometer. So 500 multiply 10 power minus 9, because nano stands for minus 9. Clear? So now I'm going to multiply the numerator and divide with 3.3 multiplied by 10 power 8 for getting the answer for the wavelength of the light in the glass medium. Clear? Okay. 2 multiply 10 power 8 multiply with 500 multiply 10 power minus 9 over 3 multiply 10 power 8. So the answer here is 3.33 multiply 10 power minus 7. 3.33 multiply 10 power minus 7, and the lambda unit is meter. So this is the answer for the second question. If you use n2 over n1, which is equal to lambda 1 over lambda 2, again you will get the same answer. So which one will be easy for you? You can just go for that. Clear? Okay. So now we have to get the answer for the third part. What is in the third part? We are going to find what should be the frequency of the light in glass. As we know, the frequency calculation, what is the rule for the calculation? Speed, which is equal to frequency multiplied by lambda, right? So I'm going to write speed. Which speed? The speed of the light in air. So V1, which is equal to frequency multiplied by lambda 1. Because generally the frequency of the light, we have to take what should be the frequency of the light in the air medium. Clear? Okay, now we are going to find the frequency. Therefore, frequency, which is equal to V1 over lambda 1. Now I'm going to substitute the value. V1 takes the value of 3 multiplied by 10 power 8, and the lambda 1 is given in the question, which is 500 multiplied by 10 power minus 9. So 3 multiplied by 10 power 8 over 500 multiplied by 10 power minus 9. I got the answer as 6 multiply 10 power plus 14, and the unit for the frequency is hertz. Clear? So this is the answer for the third question. Clear? So if you go for finding the frequency of the light in gas, so we have to always consider the speed of the light in air as well as the wavelength of the light in air. You should not take the speed of the light in the medium as well as the wavelength of the light in medium. So you have to consider the light speed in the air medium and also the light wavelength in the air medium, for only for calculating the frequency. Clear? Okay. Fifth question. A light of wavelength 600 nanometer in vacuum. So generally I told you, if vacuum will come, we have to consider that medium is, yeah, clear? Okay. So a light of wavelength 600 nanometer in vacuum enters a piece of glass. Its refractive index value is 1.52. That means it is all the times I told you. So the medium, the material medium, always we have to consider N2. Clear? So here I take this N, which is equal to 1.52 as N2. Clear? So you have to answer two questions. First question, we have to find what should be the speed, and in the second question, we have to find what should be the wavelength of the light in that glass medium. So for that, again, we have to deal with the Snell's law. So what Snell's law says, again, I'm going to write the rule: sine of theta 1 over sine of theta 2, which is equal to N2 over N1, which is equal to V1 over V2, which is equal to lambda 1 over lambda 2. So here theta 1 and theta 2 is not given, right? We are going to find what should be the speed. Let's rewrite what is given in the question first. So lambda of the air medium, which is lambda 1, which is here is 600 nanometer, right? And also the refractive index of the glass medium N2 value is given. What's the value? Which is 1.52. And here we always consider the speed of the light in the air medium is V1. So V1, which is 3 multiply 10 power 8 meter per second. And the refractive index of the air medium, I told you vacuum means air, we have to consider. Clear? So N1, which is nothing but 1. So here, if you see, we are going to find the speed. So better I can deal with these two parts, which will be easy for our calculation, right? So let's answer the first part, speed. I'm going to answer for the first question, speed. So for this, I'm going to take this region. So N2 over N1, which is equal to V1 over V2. So I have to rearrange because we are going to find what is the speed of the light in the glass. That means V2 value we are going to find. So V2, which is equal to N1 over N2 multiply with V1, right? Clear? Now I'm going to substitute the value. So N1 takes the value of 1 and N2 here is 1.52 multiply with V1, which is nothing but the speed of the light in the air medium, 3 multiply 10 power 8. Clear? So if you multiply and divide, you'll get the answer for what is the speed of the light in medium. So V2, the number 2 always stands for the material medium, right? So 3 multiply 10 power 8 over 1.52. I got the answer as 1.97 1.973 multiply 10 power 8 meter per second. So this is the answer for the speed of the light in the glass medium. And second part we are going to find what is the wavelength. So for this, what I'm going to do, either you can take N2 over N1, which is equal to lambda 1 over lambda 2, or if you want, you can take V1 over V2, which is equal to lambda 1 over lambda 2. So in this question, I'm going to take these two parts. Okay, so better we can take this one because these two are equal, right? So for finding the wavelength, I'm going to take N2 over N1, which is equal to lambda 1 over lambda 2. So I have to rearrange the value in terms of lambda 2, which is equal to N1 over N2 multiply with lambda 1. And now N1 takes the value of 1, which is the refractive index of the air medium. N2 is nothing but the refractive index of the glass medium, 1.52. And the wavelength of the light in the air medium here is 600 nanometer. So 600 multiply with 10 power minus 9. Clear? 10 power minus 9. 600 10 power minus 9 over 1.52. I got the answer here as 3.94, 3.95. Let's take 3.95 multiply by 10 power minus 7 meter. So this is the answer for the wavelength of the light in the glass medium. Clear? So this is the answer for the fifth question. Sixth question. A ray of light traveling inside a glass of index of refraction N1, which is equal to 1.65, is incident with an angle θ1 at the glass air boundary. What is the critical angle in glass if the refractive index of the air is N2, which is equal to 1? So you have to see this figure. Here, this blue color, all this blue color is the glass medium. All this orange or pink color something, right? And this N2 region, all these region are air medium. So here in this question, we are incident the light from the refractive, that means the refraction region to, that means the denser medium to the rarer medium, right? So now, question number 6. A ray of light traveling inside a glass of index of refraction N1, which is equal to 1.65, is incident with an angle θ1. At a glass air boundary, what is the critical angle in glass if the index of refraction for air is N2, which is equal to 1? So what is given in the question? You have to see the figure. So in this figure, two colors are given. So in the bottom region is a light blue color. In the top region, it's almost look like a light pink color, right? Which is N2 region. So this blue color is nothing but the glass medium, and the top one N2 is nothing but air medium. So here they gave the value of N1 as well as N2. So first of all, we have to write what is the value of N1 and N2. So here N1 takes the value of 1.65 and N2 which is equal to 1. So that means this is the refractive index of the glass medium, and this one is the refractive index of the air medium. Clear? So now in this question, we are going to find the critical angle. So what is the rule for critical angle? As we studied in the theory, critical angle should be denoted with a symbol theta c, which is equal to sine inverse of n2 over n1. Clear? So this is the rule. Now I am going to substitute the value for finding the critical angle. So sine inverse multiply with n2 1 over n1 takes the value of 1.65. So let's see what is the answer for this critical angle. Sine inverse of 1 over 1.65. So the answer here is 37.31. 37.31 degree. Clear? So this is the answer. Question number 7. A fiber optic communication systems uses a cable made of fused quartz core of index of refraction N1 which is equal to 1.458 and the cladding flexible materials of index of refraction N2 which is equal to 1.440. The speed of the light in vacuum V. So I'm going to take the speed of the light in vacuum as V1, right? So V1 which is equal to 3 multiply 10 power 8 meter per second. So find the following. So you have two subdivisions. In the first subdivisions, we are going to find what is the critical angle. So for that, first of all, we have to see the figure. So this is the fiber optic cable. You have to see the center region. This is the center region. Better I can just color this region. So this red color region is the core region, and this blue color region is the cladding region. So in this core region, value is given, which is N1. So better I can write it here. So N1 is the red color, which I shaded now. Clear? Which is 1.458, and the cladding blue color, this value refractive index of this blue color, which is N2, takes the value of 1.440. Now by using this, we are going to find what is the critical angle, as we already solved one question in the previous part, which is 6th question. The critical angle theta c, which is given by the rule sine inverse of n2 over n1, right? So I'm going to substitute the value here. Sine inverse of here n2 is 1.440 over 1.458 will give the answer for the critical angle. So let's see what is the answer. Sine inverse of 1.440 over 1.458. I got the answer as 80.98. What is the answer? 80.98 degree. So this is the critical angle. Clear? Okay. Now we have to answer the second question. So what is given in the second question? The speed of the light in the fused quartz. Clear? So we are going to find what should be the speed in the quartz. So for that, we have to use the rule. What is the rule? I'm going to use the formula for refractive index. What is the formula for refractive index? So N1, which is equal to, clear, the speed of the light in the air medium over the speed of the light in the medium. So better I can use, because we already used V1 as the vacuum, so I can change the number here. So this is V2, right? Clear? So because I already choose this is V1, So again, V1 will not come. So we are going to find in the second part, we are going to find. So why I change the number? Because in this part, in the question, they gave the value of V. So I just considered this V as V1. So the second question is nothing but V2, right? So if for solving this question, I'm going to use the formula for the refractive index. So we know refractive index is given by the rule, the speed of the light in the vacuum over speed of the light in the medium. So here the medium is fused quartz. And they said the refractive index of the fused quartz is here N1, right? So I have to rearrange this equation for finding the value of this V2. Therefore, V2, which is equal to V1 over N1. So V1 is nothing but the speed of the light in the vacuum. So 3 multiplied 10 power 8 over, and N1 is nothing but the quartz, which takes a value of 1.458. 1.458. Give the answer as 3 multiplied 10 power 8 over 1.458. I got the answer as 2.06. What's the answer here? 2.06 multiplied 10 power 8. 10 power 8 meter per second. So this is the answer. Don't get confused about why I changed this V1 and V2. But for my convenience, I just take this is V as V1 and here V1 as V2. Clear? Understand? That's it. Fill in the blanks. The reflection of the light from the smooth surface is called, we have studied in the theory, when we studied the concept of reflection, we studied two cases. What is the reflection of the light from the smooth surface? What is the reflection of light from the rough surface? Actually, these first two questions we already studied in the theory class, right? So generally, if the light reflection will be on the smooth surface, that reflection is called as specular reflection. What's the name for that? Reflection of the light from the smooth surface is called as specular reflection. Likewise, the light from the rough surface, the reflection of the light from the rough surface, which is called as diffuse reflection. Diffuse reflection. So this is the answer for the first question. Third question. The law of reflection states that the angle of incidence is equal to the angle of reflection. That is the law for reflection, right? So the angle of incidence must be equal to the angle of reflection. So the answer here is angle of reflection, right? Okay. And the last part, which is fourth question, the ratio of the velocity of the light in the free space to the velocity of the light in the medium is known as we studied the formula for the refractive index. What is the formula for the refractive index? N, which is equal to V1 over V2. Here V1 is nothing but the speed of the light in the vacuum. Here vacuum is nothing but the free space. Over V2 is nothing but the speed of the light in the given medium. So that means V1 over V2 is nothing but N. What is this N? This N is nothing but the refractive index. So the answer for the fourth question is refractive index. Clear? Okay. Now we have to come for the ninth question, which is match the following. So you have four questions. What is Snell's law? We studied Snell's law, which is equal to sine of theta 1 over sine of theta 2, which is equal to n2 over n1, which is equal to v1 over v2, which is equal to lambda 1 over lambda 2. As we have many parts, but here if you take this part, okay, move this n1 to the left hand side of the numerator, you can move this sine theta to the right hand side of the numerator, right? By that, this equation will become n1 sine theta 1, which is equal to n2 sine theta 2. So we have the answer here. So for the first question, the answer is this one. And the second question, what is the speed of the light in vacuum? We solved many questions. The speed of the light in vacuum, which is considered the speed of the light in air, which takes the value of 3 multiplied 10 power 8 meter per second. And third question, critical angle. Critical angle should be denoted with a sign, with a symbol theta c, theta suffix c, which is critical angle. Refractive index of the air. So the constant value for the refractive index of the air will take the value of 1. So here the answer for the fourth question is n, which is equal to 1. Clear? So this is the answer for the ninth question. That's it. Thank you.